Today we're going to cover day 1 of section 2, so 2.2a. Today we're going to learn about functions. So for something to be a function, each x value can only have one y value. So if you're given a list of ordered pairs, the x's cannot repeat. It has to have a different y. The y's can repeat. Now what we're going to be introduced here is function notation. What you're used to seeing is, for example, y equals mx plus b, so y equals x plus 1. So now instead of y equals, it's going to be f of x equals x plus 1. Now they may not use f always, it could be g of x. It's just going to be a variable or a letter, and then whatever variable is in the function, that's what will be in parentheses. So function notation is just a fancy way of saying y equals. So let's go ahead and take a look at our first example. And it wants us to determine if any of these sets represent a function. So whenever you're given a list of ordered pairs, remember in your ordered pair, the first number is x, the second number is y. So when it's a list of ordered pairs, all we're doing is checking to see, are all of the x's in each ordered pair a different number? So this is an x, 1, -2, 3. They are all different numbers, so yes, this is a function. However, number 2, if I look at all my x's here, I see I've got a 1 here. And then as soon as I look at the next one, I got another 1. Soon as you see one of the x's repeat, you can stop and say, nope, not a function. Notice it still repeated another time. Now, when you have a mapping diagram, like these ovals, or they look sort of like ellipses, as long as one line or one arrow is coming out of each x, it's a function. So this would be a function because each one of my x values is paired with exactly one y. I could turn these into ordered pairs. It would become the ordered pair 1, 2, -2, 4, and then 3, 1. So these would be the ordered pairs. You're looking at the arrows. On number 4, however, notice the number 2 here, -2, has 2 lines or 2 arrows coming out. So this would not be a function. The ordered pairs that it creates would be 4, 1, -2, 0, and -2, 1. And again, notice the -2 is repeated, so that's why it's not a function. Okay. The next way to determine if something is a function is if you're given a graph of whether it's a vertical line, whether we're going to use the vertical line test. So what we would do is when you're given a graph, you're going to take a vertical line, and if you draw a vertical line down your graph, and if it intersects your graph at more than one point, then the graph is not a function. So let's go ahead and first do the graph, then we'll talk about from an equation. So all linear functions or all graphs of lines are going to be functions unless it's vertical. Can't be a vertical line. So for example, if I drew a line here, this would be a function because what I'm trying to do is not make it successful. I'm trying to find a place where when I draw a bunch of vertical lines down my graph, see if it would hit more than once. But notice it's only hitting the blue line here one time, here one time. So all linear graphs, except for when it's vertical, are functions. So this would be a function because it passes the vertical line test. Now, whenever I have a graph of a parabola, so my parabola could be graphed either a happy parabola facing up or a sad parabola. It looks like he's frowning. This would also be a function because once I draw, and again, these sides of this parabola are getting wider and wider. Now, these U's are 2 different parabolas. So let me go ahead and, actually, let me erase that. So this would be a parabola. So if I draw a vertical line, notice it only hits it once. No matter where I draw it, it's only going to hit my red line one time. Now, even if the parabola is facing downward, so if I were to draw another parabola, and again, could be here, and again, my vertical lines always only hit it one time because those endpoints of that parabola are getting wider and wider. So all quadratics are going to be functions as well as the linear functions. Now, when I have a hyperbola or a circle or an ellipse, these will not be a function. So for example, if I were to graph a circle on my graph, notice when I draw my vertical line, it hits it here and here. So this one is not a function. And even if it's a hyperbola looks like a parabola turned sideways. So if I were to graph this and then draw my vertical line, notice it fails. It hits it 2 times. So anytime you draw a vertical line down through your graph, if it touches it 2 times, more than once, then it's not a function. So this one is also not a function. Now, when you're given an equation, anytime you have something in y equals mx plus b form, any linear equation is going to be a function. These are functions. However, whenever you have a y raised to an even power, like for example, the equation of a circle is x squared plus y squared equals 9. Whenever the y variable is raised to an even power, it's not a function. Same thing if it were a hyperbola. The other thing is you can't have y in absolute value, and you can't have y underneath a square root. So you couldn't have the square root of y equals a number. This is not a function, or y in absolute value. So when you see these, you're going to recognize that it cannot be a function. 1, determine whether y is a function of x. So this one, if you think about it, you could rearrange it and you could get y equals x squared plus 1. This is quadratic. This is a function. You can have an x squared. The next one, notice it's got a y squared. So this one is not a function. If you were to rearrange this and solve this, you would get negative x plus y squared. And then what you could do is add the x. Y squared equals x plus 1. You would square root it, and y would equal plus and minus this, and this is not a function. All right, next one, same thing, circle here. Got a y squared, not a function. And then this one, this is a parabola. When it's an x squared, it's a parabola, it's quadratic. This one's yes. So the x's can be squared, however, the y's cannot. We could rearrange this one and solve it for y by adding the 4x squared. And we get y equals 4x squared plus 36. It's quadratic. All quadratics, which are parabolas, they're functions. Next, we're going to learn how to evaluate a function. Okay, so evaluating a function, again, the function notation, they're going to give you a value of what they want you to plug in. It'll either be a number or an expression, and the number that they want you to plug in will be in the parentheses. So for example, again, you're used to looking at that as y equals, say, x minus 1. It'll be given to you in function notation now. And then in the parentheses, they're going to give you the value that they want you to substitute for x. So where I see x, I replace it with a 4. And then I get f of 4 is equal to 3. And if you think about it, remember, f of x is y. So this becomes an ordered pair. And what you plugged in for x was 4. And what you got as the answer is the y of the order pair. So when you're plugging in and substituting these values into the functions, you're actually creating order pairs that you could use to graph the functions. Now, notice up at the top, there's two different functions up there. We have the f of x function, which is x squared plus 3x plus 1. And then we have the g of x function, which is the negative x squared plus 4x plus 1. Pay attention to the letters to figure out which function you're using. So for the first one, number 1, notice the variable f. So I'm using this equation. So I'm going to take x squared plus 3x plus 1, and every place that I see x, I'm replacing it with a 0. And then I'm going to follow order of operations, and I can see that f of 0 is equal to 1. And again, if they ask you to write it as an order pair, it would be 0, 1. For number 2, again, same function. It's the f of x function. So again, I'm going to take x squared plus 3x plus 1. Every place that I see x, I'm replacing it with a 1. Going to follow order of operations, and then I'm going to add 3 plus 1 plus 1, and I get 5. So f of 1 equals 5, and again, as an order pair, what went in for x was 1, what came out for f of x or y is the 5. Let's try the next one. We're still using the same function, the f of x function. So the x squared plus 3x plus 1, replace x with negative 1. I'm going to follow order of operations. Negative 1 squared is positive 1. Positive 3 times negative 1 is negative 3. And now I'll add left to right. 1 minus 3, negative 2, plus 1 equals negative 1. So f of negative 1 equals negative 1. So the order pair, negative 1, negative 1. For number 4, I'm using, now the letter changed, I'm using the g of x function. Be very careful when you've got a negative sign in front of the variable. So what I'm going to replace here is my g of x, and it's negative x squared plus 4x plus 1. So I'm leaving the negative sign. In here, I'm putting the 2, and I'm squaring it, and then plus 4 times 2 plus 1. Negative sign comes down. 2 squared is 4. 4 plus 2 is 8. Now add left to right. Negative 4 plus 8 is 4 plus 1 equals 5. So g of 2 equals 5. And again, written as an order pair, 2, 5. For number 5, they're asking me to plug in a variable. So same thing, I'm just going to rewrite the function, but instead of putting x there, I'm going to put the t. So again, the original is negative x squared plus 4x plus 1. But now they want me to do g of t. So every place that I have x, I'm just going to now put in the letter t. So negative t squared plus 4t plus 1, and I'm done. If it asks you to write it as an order pair, it would be t, comma, and then negative t squared plus 4t plus 1. And then number 6, again, same function, but again, a variable. So I'm doing g of x plus 2. So again, here is my original. So again, every place that I see x, I'm now putting x plus 2. So negative, and then x plus 2 squared plus 4 times x plus 2 plus 1. I need to FOIL this guy. And then I got to distribute the negative sign. You have to follow PEMDAS. Do not distribute the negative sign first. That's not what order of operations tells you. You could think of this as a -1 that you're going to multiply later. So let me distribute or FOIL first. So x squared plus 4x plus 4. And then now I could distribute the negative sign, but let me go ahead and distribute the 4 to the middle term. So now this becomes -x squared, -4x, -4 plus 4x plus, and I'll add these, and I get 9. Okay, so now I need to combine like terms. Notice these are the same, so these are going to cancel. And then I can add the -4 and the 9. Nothing to combine with the -x squared, and I'm done. So G of x plus 2 is equal to that, and written as an ordered pair, x plus 2, and then -x squared plus 5. Next one, this time we have the h of x function. And again, we're doing exactly the same thing. So my h of x function is going to be 10 minus 3x squared. They want me to plug in a 2 for every place that I see an x. You're following PEMDAS, so evaluate the exponent first and then multiply, and you get 10 minus 12, and that gives you -2. So h of 2 equals -2, so the order pair 2, -2. I'm going to go ahead and do it. It's really going to turn into the same answer. I'm going to modify it and do it with a -4, but let me go ahead and do this one. So again, you're going to plug it in, h of -2, and you get 10 minus 3 times -2 squared. -2 squared becomes +4. 12, this becomes a 12, and then a -2. So this order pair, h of -2, -2, -2. Let me go ahead and just do a different one. Let's do a -4, just for practice. So 10 minus 3 times -4 squared. Evaluate the exponent first, then multiply, then subtract. So h of -4 equals -38. So again, the order pair, -4, -38. And then let me do the h of x minus 1. So again, yes. Okay, so this is just a new problem that I made up just to give you extra practice. So now let's go to do number 3. So again, we're going to take h of x, 10 minus 3x squared. This time for x squared, I'm replacing it with x minus 1. So then now I need to FOIL that, then distribute. Gotta follow PEMDAS. Do the exponent before you multiply. This becomes x squared minus 2x plus 1. Now I can distribute the 3. -3x squared plus 6x minus 3. I can combine these like terms. So I get -3x squared plus 6x plus 7. And that's what h of x minus 1 equals. So as an order pair, it ends up being x minus 1, and then comma, -3x squared plus 6x plus 7. All right, next. All right, so this is a piecewise function. Notice the function has two different expressions here. So what they want me to do is whenever the x value, the number that's in the parentheses here, whenever this number is going to be less than 0, I'm going to use the first equation. I use this one. However, whenever the number is greater than or equal to 0, I'm going to use this expression. So for the first one, notice it's less than 0. So what I'm going to be using is the x squared minus 1 for this one. This one is equal to 0, so I'm going to use the x minus 1 for this one. This one is greater than 0, so I'm using the x minus 1. So you have to look to see which one to use when they give you a function with more than one expression. I'm going to go ahead and replace -1 for my x. So -1 squared, let me do this in purple, -1 squared minus 1, so I'm plugging in into this x, I'm plugging in the -1. So then -1 squared is 1 minus 1, and I wrote the wrong. Let's change this to a plus sign as well. Let's change this function, this expression here to a plus sign. So we're going to do this as an addition problem. So then this gives me 2. The other expression is good. So now let me plug in 0, 0 minus 1, and I get -1.
Why did you change the sign, Ms. Gordon?
It's just a typo of why I'm changing it to a plus sign. Now, for A here, the ordered pair we created that we're going to be graphing is the ordered pair -1, 2. Then for B, the ordered pair we just created is going to be 0, -1. And then the last one, again, this time I'm plugging in 1. And then this ordered pair is 1, 0. All right, I know there's not a graph here, but I'm going to go ahead and graph it. I'm going to show you how to graph. Now, we're going to be going more in depth with piecewise later on. But for now, a nice little introduction. Just going to do a rough sketch here. So I'm going to go ahead and graph the ordered pairs. So really what I'm doing here is I'm going to first graph this one right here. So I'm graphing x squared plus 1. I've only gotten one ordered pair from that, and that's when I plugged in the -1. And I got the ordered pair -1, +2. Now, I can also plug in 0, but when I plugged in the 0, it's going to be an open circle. So just to give you another ordered pair, remember it's this, x squared plus 1. If I plug in 0, I get y equals 1. So I'm going to put an open circle because look at the inequality here. It can't be equal to 0. It's got to be less than 0, but I still need to get my parabola going here. Then for the other one, it's the x minus 1, and again, you could do it like this. So you already have your ordered pairs. It's 0, -1, closed circle, because it's equal to, and then 1, 0. This one is a linear equation, so it's going to be a straight line, no curve to it. So when it's an x squared, it's a parabola. If it's just the variable x, it's linear. So this is a piecewise function where you graph more than one function on the same graph. Now, this one's a little different. Notice this time, they're not giving me a value of x. They're wanting me to find what do I get for x when I set my function equal to 0. This is how you can find x-intercepts because, again, remember, f of x is just y equals. So really what we're doing here is we're setting y equal to 0, which is really our f of x. And that's what they just told us to do here. So I'm going to go ahead and take my function. I'm going to set -2x. So really what I'm doing is 0 equals -2x plus 10.
Sorry, could you also do?
So I'm going to just flip it around. So it's -2x plus 10 equals 0. Subtract 10. -2x equals -10. Divide by -2. And x equals 5. This ordered pair is your x-intercept. It's the ordered pair 5, 0. Because again, x-intercepts, remember, are a number and then comma 0. So really all we're doing is setting our equation equal to 0, or our function equal to 0. So number 2, x squared minus 5x plus 6 equals 0. This is a trinomial that I need to factor. It is factorable. If it couldn't be factored, you'd be doing quadratic formula. So here, or quadratic equation formula. So I'm going to find the factors of 6 that give me negative 5. And the signs have to be the same to get a positive 6. So it's negative 2 and negative 3. Believe it or not, this trinomial is hard for a lot of people because some people pick 6 and 1 because they don't realize that the signs had to be the same. So be very careful even on these easy ones. So now I set x minus 2 equal to 0, x minus 3, add 2, x equals positive 2, x equals 3. So when we go to graph this, these are our x-intercepts, and this is a parabola. So our graph would be touching 1, 2, 3. Our graph is going to touch the x-axis right here and right here, and it's going to be a parabola going up. I don't know exactly where that vertex is, but that's where it would be touching the x-axis. These are x-intercepts. Let's go ahead and try the next one. Again, I'm going to set this equal to 0. Now, you could also use the square root method here, but I'll go ahead and factor it. X plus 4, x minus 4. And then set each of the factors equal to 0. Subtract 4. X equals negative 4. Add 4. X equals 4. So negative 4 comma 0 and positive 4 comma 0. Then for number 4, this is a cube. But notice we can pull a GCF out. So at first you might think, oh, I got to do SOAP, but not necessarily because it's got a GCF. You should always look for a GCF first. I can divide them both by x. And now I have the difference of 2 squares. So x times x minus 9, x plus 9. Set each of them equal to 0. And now solve. The first solution is already done. It's just x equals 0. Here, x equals negative 9. So I have 3 answers here, 0, 0, 9, 0, and negative 9, 0. And then number 5, again, what I'm going to do is 5 minus 6x over 3 equals 0. I'm going to get rid of the fraction first. I could times both sides by 3, and then I just get 5 minus 6x equals 0. I can add the 6x, and I get 5 is equal to 6x. Divide by 6, and x equals 5 over 6. As an ordered pair, 5, 6, comma 0. This time, they want us to find the value of x where f of x equals g of x. So all I'm going to do is set the two expressions equal to each other. So f of x is x squared plus 1. G of x is 3x minus x squared. I need to get my like terms together so I can add x squared. And this gives me 2x squared plus 1 equals 3x. Notice it's going to be a trinomial, so I have to factor this. Let me move the 3x over. So 2x squared minus 3x plus 1. Now, I can either factor by grouping or guess and test. This is easy enough probably to guess and test because the factors of 2 are just 1 and 2, and the factors of 1 are 1 and 1. However, if you want to see the whole factor by grouping, you would go ahead and multiply. So 2 numbers that multiply to give me 2, but add to give me negative 3. And that's going to be negative 1 and negative 2. So let me go ahead and factor it over here. So 2x squared. And then I could put minus 2x minus 1x plus 1 equals 0. Make a red group and a blue group. GCF of red is 2x, so x minus 1. GCF of blue is going to be -1. Put these two together, so the two factors are 2x minus 1 and x minus 1. So now I need to set each of these equal to 0. So 2x minus 1 equals 0, x minus 1 equals 0. Add 1, divide by 2, x equals 1/2. Over here I'll add 1, x equals 1. So again, as if it just asks you to find what x equals, it's 1/2 and +1. And then the last one, same thing. So we did not plug in a 0 here. We didn't set it equal to 0. We just set them equal to each other. So these are the values of x where the two functions will equal each other. So let me go ahead and now do the last one. It's x squared minus 1 equals -x squared plus x plus 2. I need to get my like terms together. So I'm going to add x squared again. 2x squared minus 1 equals x plus 2. Again, I'm going to move my terms together and set up my trinomial that can be factored. And then lastly, move the 2 over. And then I'm left with 2x squared minus x minus 3 equals 0. So now what I need to do is, if I want to factor by grouping, I'm multiplying the beginning and the end. So two numbers that multiply to give me -6. That will add to give me -1. And those two numbers are going to be -3 and +2. So let me go ahead and 2x squared I'll do the plus 2x minus 3x. It doesn't really matter how you put them in here. You're going to get the same answer either way. So blue group, I'll do a purple group. GCF of blue is 2x, so x plus 1. GCF of purple is going to be -3. Because again, once you do this factor by grouping, these two need to look the same. So x plus 1, and then put these two together and set it equal to 0. Now, I saw some people on the test that tried to do stuff like this mentally, and then you wrote the answer upside down. So just be careful. Take the time to write it out. This answer, once you do this fraction, should be 3/2. Someone on the test told me it was 2/3 because they tried to do it in their head and they messed up. So take the time to write it out because sometimes your brain tricks you. So the two answers here are going to be -1 and +3/2. And that is it for 2.2a, your introduction to functions.